Hello guys, welcome to Engineering Insight Academy. Today I want to talk about Bernoulli equation. We want to work a Bernoulli question from March 2023, question number A4, which have got 8 marks. So we know that a Bernoulli question, first we have to make the coefficient of dy over dx 1. So we say dy over dx, we divide by cos x throughout. Here we say plus sine x over cos x dot y is equals to y to the negative 2 dot sine 2x over cos x. Now we have to deduce our small n. Small n, it is the power of y here, which is negative 2. And we know that z is given in the form y to the power of 1 minus n. And so if we put our n, which is negative 2, we get y cubed. Now we differentiate z, we get dz over dx. If we differentiate y here, we bring down the power, which is 3, and we less 1, we left with y squared. But we differentiated y, so we add dy over dx. Now, you see this part that you differentiate, the 3y squared, you multiply both sides by 3y squared. So if you multiply here by 3y squared, you get 3y squared dy over dx, plus if you multiply by 3y squared here, you get sine x over cos x. If you say 3y squared times y, you get 3y cubed is equal to, if you multiply here by 3y squared, you get 3 times sine 2x over cos of x. Now, you see this part is the same as this one, but this part is the same as dz over dx. So dz over dx, and here plus this one is the same as 3 sine over cos is equal to tan of x. 3 tan x y cubed is equal to 3 sine 2x over cos of x. Then dz over dx plus 3 tan x, and y cubed is equal to z. So we substitute y cubed by what? By z is equal to, here we know that the identity of sine 2x is equal to 2 cos x sine x. So introduce 2 cos x sine x, multiply by what? By this 3 all over cos x. Cos and cos, they will cancel each other. So we have dz over dx of 3 tan x by z is equal to, here times here, we got 6 sine of x. Now this one is the differential equation, which uses the integrating factor now. So we have to introduce the integrating factor. Integrating factor is e to the integral of the coefficient of z. Since we are dealing with dz over dx, the coefficient of z is equal to 3. Tan is the same as sine x over cos x, like this. Then by what? By dx. We say e to the integral of, we factor out 3 sine x over cos x by what? By dx. If we integrate here, we get e to the negative 3 ln of what? Ln of cos x. because we use the recognition method, if we integrate cos of x, we get negative sin x. So we introduce a negative and we introduce ln of what? Of cos x. This one is the same as e to the ln of 1 over cos cubed of what? Of x. So our integrating factor is 1 over cos cubed of x. This is our what? Our integrating factor. So we take this integrating factor and we multiply everything here. So 1 over cos cubed of x dz over dx plus 1 over cos cubed of x multiplied by 3 tan of x by what? By z is equals to 6 sine of x over cos cubed of x, like this. Now we have to find the function that we differentiated to get this one. So it is d over dx of what? Of z over cos cubed of what? Cos cubed of x. We differentiate this one to get this one. This one is equal to 6 sine of x over cos cubed of x is the same as cos x dot cos squared of what? Squared of x, which is d over dx of z over cos cubed of x is equal to, this one is 6 tan x, and 1 over cos squared of x is sec squared of x. Now we have to integrate both sides, so we integrate here and we integrate here with respect to dx, with respect to dx. Dx and dx will cancel and the integral sign will remove it, and we have z over cos cubed of x is equal to 6 integral of tan of x sec squared of what? Sec squared of x by dx. So now we introduce the identity of sec squared of x, which is 1 plus tan squared of x. So z over cos cubed of x is equal to 6 the integral of tan of x. We introduce tan squared of x plus 1, which is the identity of sec squared of x, then by dx. So z over cos cubed of x is equal to 6 the integral of, if you multiply tan by this one, we get tan cubed of x. If you multiply tan by this one, we get plus what? Plus tan of x. This one all by dx. Then the integral sign is distributive, so we get 6 the integral of tan cubed of x by dx plus 6 the integral of tan x by dx, z over cos cubed of what? Cos cubed of x. Z over cos cubed of x is equal to 6 the integral of tan cubed of x by dx. If we integrate here, 6 the integral of tan of x. If we integrate tan of x, we get negative ln of cos of x. So we get negative 6 ln cos of what? Cos of x. So z over cos cubed of x is now equal to 6 the integral of tan cubed of x by dx minus 6 ln of cos of x. Now we want to integrate this one. So we integrate this one at our side. So we left our answer at z over cos cubed of x is equal to 6 the integral of tan cubed of x by dx minus 6 ln of cos of x. So we say aside aside, we now want to integrate this one. So we integrate tan cubed of x by dx. And when you have your answer, don't forget to multiply the answer with what? With 6. So this one, we use the reduction formula to integrate such type. So we formulate the integral of tan to the n of x by dx is equal to or identical to the integral of tan to the n of x. We introduce a negative 2, so it's now tan n to the negative 2 of x by tan squared of x. By what? By dx. So now we introduce the identity of tan squared of x. We know that sec squared of x is identical to tan squared of x plus 1. So tan squared of x is identical to sec squared of x minus 1. So we say the integral of tan to the n minus 2 of x, open bracket, we introduce sec squared of x minus 1 by what? By dx is equal to. So we multiply this one, and we know that the integral sign is distributive. So we got the integral of tan to the n minus 2 of x sec squared of x by dx minus the integral of tan to the n minus 2 of x by dx, like this. So now we have to find a function that we differentiate to get this one. So this function that we differentiate to get this one is tan to the n minus 1 of x over n minus 1. So if we differentiate this one, we get this one. Let's prove it. If we say d over dx of tan to the n minus 1 of x over n minus 1, like this. We bring down n minus 1 and over n minus 1. Then we less another 1 here. We get n minus 2 of x. If we differentiate tan, we get sec squared of x. This one and this one will cancel. So this one is the same as this one. So the integral of this one is this one. Then we say negative. This one at reduction formula, we denote it by I n minus 2. Then we introduce integral of tan to the n of x, and the integral of tan to the power n of x by dx is denoted by in. Now we want to proceed. So we know that n represent this n, and we know that at our case n is equal to 3. So we came here and say I3 is equal to tan. If we put 3 here, we get 3 minus 1, which is 2. We get tan squared of x. If we put 3 here, we get 2 minus, if we put 3 here, we get 1. And you test when you get this one, you came here to your reduction formula and put 1 here. If you see that you are getting I to the negative number, then there is no such a thing at reduction formula. So you go back here and say tan squared of x over 2 minus, you put 1 here, you left with the integral of tan of x by dx. Then tan squared of x over 2 minus, if we integrate tan, we get a negative ln cos of what? Of x. And tan squared of x over 2, negative times negative will get positive ln cos of what? Of x. Then we introduce a plus c. This is I what? I3, or is the same as the integral of tan cubed of what? Of x by dx. Right? When we get this one, we go back to our what? To our reduction formula and say, we go back to our equation and say z over cos cubed of x is equal to 6, open a square bracket and introduce tan squared of x over 2 plus ln cos of x plus a constant c minus 6 ln cos of what? Cos of x. So if we multiply by 2 here, we say 3 tan squared of x. If we multiply by 6 here, we get plus 6 ln cos of what? Of x plus 6c minus 6 ln cos of what? Cos of x. Then 6 ln cos of x minus 6 ln cos of x, we get 0. And we're left with tan squared of x plus c is equal to z over cos cubed of x. Then we multiply here or both sides by cos cubed of x. We're left with z is equal to 3 tan squared of x plus 6 multiplied by cos cubed of x. Now we get 3 cos cubed of x tan squared of x plus 6 cos cubed of x times what? Times c here. So our final answer, we know that from where we started, z was equal to y what? Y cubed. So we introduce y cubed here and say 3 cos cubed of x tan squared of x plus 6 c cos cubed of x. So this is our what? This is our solution or our general solution for our Bernoulli equation. So thank you guys. Please subscribe to my YouTube channel, Engineering Insight Academy, and don't forget to comment. Thank you.